afternoon, perhaps good evening to some of you guys. It's great to be back on the webinar series again. So today we will talk about how we can achieve or even simplify cross-cloud application resilience for some of the applications that are cloud native and so on. Before we begin the webinar, I am Govindra Rangaswamy, CEO and founder of Appranix. We have a tremendous team that has created this wonderful product about entire thing about simplifying the application-centric disaster recovery for cloud-native applications. As the typical mechanism goes, we will record this webinar so that you can review and or even share with other people within the organization or on the social media if you see fit, so that others can also get to know about Appranix, get to know about what's possible with respect to cloud application resilience. So overall, application resiliency means a lot of things to a lot of people, but at the end of the day, achieving true cloud application resiliency requires a lot of effort, a lot of capabilities that can only be achieved with a diligent approach for managing your applications. So Appranix offers a site reliability automation platform that delivers a true cloud application resiliency in the market today for applications that are running on the cloud infrastructure. And we have been recognized by leading analysts like Enterprise Management Associates as one of the top 3 platforms for application-centric automation. You can download the report and check it out. We are a secure enterprise SaaS platform with 99.9% SLA. So we basically manage our platform using our own services. So we become the first customer, if you will. And for enterprises, we offer 24/7 support. Given that, there are 2 distinct things that are happening. They are kind of intermingled, but they are 2 distinct things depending on type of organization that you are involved with. One is something called cloud-enabled applications. These are, again, modern applications. When I say modern applications, either the infrastructure is changing, because of which the applications are getting modernized to a certain extent. For example, legacy applications are being lifted and shifted over to the hyper converged cloud platforms such as Microsoft Azure, Google Cloud, and AWS, and so on. And these are, again, called cloud-enabled applications. And on the other hand, cloud native applications that are created using modern infrastructure services like Kubernetes and containers and so on. So those come with tremendous benefits as well. So on the legacy side, you get to enjoy the resilient global infrastructure of these hypercloud platforms. And they offer continuous improvements. Every day you will see a new feature getting released or enhancement to the existing infrastructure services getting released from these hypercloud platforms. And they offer on-demand capacity. You can scale very easily and then pay per use depending on what you use. Those are tremendous innovation on top of the infrastructure that we have gotten used to. So, and on top of that, you have a consistent infrastructure that delivers tremendous possibilities for achieving application resilience. Kubernetes, on the other hand, has enabled container-based applications in terms of what was not possible before, be it faster application delivery because all the dependencies are wrapped in the same container so that you don't have to worry about an app that used to run on the developer machine. Now it's not running in production environment. That gap, the production cliff issue has gone away with container-based application. Kubernetes offers the tremendous capability to scale. In fact, most of which is completely automated. So the infrastructure management problems have kind of come down a lot. and better infrastructure utilization as well. So in terms of packing more application containers on the same virtual machine or even the physical machine offers tremendous opportunities for increasing the cloud infrastructure, right? And those are like some of the innovations that have fueled what is possible with application resiliency. Now, all these modern applications, are being compared with applications like Amazon.com or Netflix or any of these modern applications, including Gmail, for instance. All these SaaS applications have really redefined the expectations, up the expectations that the modern applications need to be completely resilient. No matter what happens to the infrastructure, the applications need to be 100% available. And that's a huge expectation, especially for applications that have been migrated from the traditional infrastructures where enterprises used to create their own data center, customize the data center by buying equipment from all over the place, and putting so much energy in terms of managing that infrastructure to create the availability necessary. And now the cloud platforms offer huge reliability in terms of global infrastructure, mainly because you do not have to worry about the capacity for your applications. You can very easily scale. But on the other hand, expectations on the resiliency side, availability side, have increased tremendously as well. So if you're thinking about running an application at 99%, which again is a big problem, because even thinking about maximum disruption per month about 7 hours, even if you deployed a bad deployment, for example, changing configuration of an application, that could introduce 7 hours of disruptions if you're not careful. So, if you think about improving that availability by reducing the disruptions from 99% to 99.9%, that's a whopping 50% improvement, right? And that brings down the available disruption time frame, right? The time frame where your applications could only be down for about 2 minutes. I mean, that's huge, huge expectation. And, that requires a lot of ability from your operations perspective. And that's where the site reliability engineers are coming up with capabilities that potentially could enable some of these application availability requirements. Now, what is really difficult or unexpected things is that the disruptions are so many. Disruptions could come from a single bad application deployment, right? We have gone through many of in our own deployment scenarios for maintaining and managing our service at 99.9%. A single bad deployment to one of the cache services could actually disrupt the application, because the cache layer enables the browser layer to communicate through to the backend. And now, if you messed up the cache layer because of a bad deployment, now the entire application is not responsible. So what do? You will have to figure out a mechanism to borrow time, right? Enable some other mechanism to bring up that application first. Second thing is that cloud is great. They are global, resilient infrastructure. But on the other hand, when you compose your applications, you are making use of many different infrastructure services or platform services. So your application is not going to be made of a bunch of just virtual machines, because in the backend, you have storage to worry about, the network layers to worry about. All of that need to be properly managed. And then you are bringing in the load balancer, you're bringing in the DNS services, you are bringing in the network services, other services, plus any other services associated with respect to platforms. On the other hand, making the entire application possible. Now, if any of these individual services come down, right, it's quite possible that all of these services do not offer the same type of SLA, even it is 99.9% or 99.99% availability, means that they are going to be down at some point in time. And even the cloud providers clearly voice opinion that you will have to really take care of the application side. So individual cloud service failures could disrupt your applications. Now, the third thing is all the cyber attacks. Ransomware attacks are an everyday phenomenon. I think Texas, all the Texas counties are going through right now some kind of a ransomware attack. The ransomware attacks are particularly targeting the county applications. Those applications are down because of which, all the services provided by the Texas government, individual county governments are suffering. And now you could either pay the ransom and get back your application, but overall your application has already been disrupted. So what do you do? In those situations, you have to be prepared with an alternative option. Fourth situation, even though the cloud failures are rare, right, and they are occurring. A couple of months ago, Google, one of the regions on Google Cloud went down because of a networking problem. So even though they are rare, they do occur, right? So when you go, if you're a SaaS application, when you go and talk to your end user customers, they might even demand the proof that you have a mechanism to make your applications reliable, even in the case of failures in the backend, meaning cloud platforms. So in those cases, you will have to at least test those application resiliency, application reliability once in a while, make sure that those tests are proper, and so on. So, the question is, can I at least test the resiliency to become compliant, right? You have to have compliance for many reasons, including SOC compliance or SOX compliance or ISO compliance, depending on the country that we are talking about. So the site reliability engineers, this is a nice picture that I found on the web. It's a badass miracle worker is not an official job title. It is a site reliability engineer who is supposed to manage all of your applications, or even a particular distributed large application has to be managed by the site reliability engineer or the engineering team. That's a tremendous effort and a lot of work. And that's where we come in. You have the shared responsibility model with the cloud service provider. So you have the infrastructure and service availability guaranteed to an extent based on the SLA. And the service security is also taken over by the cloud provider, which is great. And they give you access to the API for you to manage, or the console. And the consoles have SLAs as well. Typically, it's about 99.5% SLA for the API and console access. Whereas the customer responsibility, the cloud customer responsibility comes when you deal with your application. So application implementation, obviously lift and shift or configuration changes and so on. So all your operations are your responsibility, is no brainer. Application availability is less understood situation with enterprises that have moved to the cloud. Application availability is your responsibility, meaning protection, resiliency, all of that. Application security is your responsibility, right? So it's a clearly defined shared responsibility model that used to be kind of difficult to educate 5 years ago. Now it's all becoming kind of a very well understood concepts. Now, given that, the goal here is to decrease these unplanned disruptions by 50% and up to 300% if it is possible, right? So if you are moving from 99% to 99.9% goal, then you're talking about at least 50% improvement. I mean, that's a huge one, 50% improvement, right? I'm sorry, this is a 300% improvement. I mixed that up. If you're moving from 99.9 to 99.95, then you're really kind of, huge improvement, additional 300%. So anywhere between 99 to 99.95, it's a 300% improvement. It's a huge difference if you just moved from your data center to your cloud platform. So in those situations, any of your platinum tier applications, the platinum tier applications require a lot of capacity, a lot of configuration. So we are not talking about those where you are managing those applications at 5 nines. 5 nines is, it's better that you have the replication properly planned out. But anything just below the platinum tier, tier 1 to tier 3 applications, right? Even the tier 4 applications, if you're not careful, they could be down for days, right? So you have to be really be planning for the resiliency. So the goal is to decrease this unplanned disruption so that you can manage the resiliency appropriately. Now, the application resilience, like I mentioned, is your problem, not the cloud service provider problem. So if you think about it, what Gartner has been saying, I mean, if you refer to Gartner Cloud Planning Guide, that's the latest one that you can refer to, they say the data replication options are available with the cloud providers, right? To ensure the critical data is available in more than one region, cloud region, right, from the same provider. Whereas the DR orchestration, automation, testing, along with all the design considerations are customers' responsibility. And it is not just you, the inquiries around cloud resilience have been increasing ever since 2016. I mean, it's at close to 45% and the compound annual growth rate, and it's growing as well. So by now it's like 100% improvement in terms of cloud racing. Everyone is screaming to ask for it, or they have figured out a mechanism to fail back. I mean, there are different architectures for different types of applications. Some of the well-architected framework from providers like AWS clearly outline the ability to fail over within the same region using two dual zone architectures. But typically, when you lift and shift your application, the first landing place is one particular zone within a particular region. And you have to be careful in terms of how you architect your application going forward, even if you're modernizing it. So if you check out the AWS Will Architect framework, there are about 5 pages worth of application resiliency checklist. So that covers multiple components around application readiness checks. The important part is that you have to make sure that your application environment configurations and dependencies are properly covered as well. So there are, you could, search for on Google AWS Will Architect framework. You can download the April white paper, which is about 55 pages long, and out of which, if you go to the pages between I think 50 to 55 or 57, you could check out all the requirements. So, and these number of pages, keep changing anyway. It could be 75 now. So all the network checks, storage checks, security and logging. Now, when you bring out your application in another zone or something like that, you have to make sure that your logging is properly enabled, which apart from application environment configurations, your logging should be enabled so that your application can continue to run. Now, there is a current approach, obviously, especially when you think about cloud infrastructure services with all the compute, networking, load balancing, all of that. And you don't have to deal with nitty-gritty details of these infrastructure if you're running Kubernetes. So Kubernetes services do decrease the reliance on the infrastructure, but that doesn't completely get rid of the reliance on the infrastructure. You will have to manage the worker nodes for Kubernetes. The master node is taken care of. And again, you'll have to opt for the proper resiliency around the master node as well. So it depends on how you want to manage. But on the worker nodes, you will have to manage the infrastructure yourself. So depending on the type of application, the number of namespaces that you're running, the amount of work could vary. So the typical workflow is that if you're planning to do any of this, you will end up doing custom automation, obviously, some kind of a snapshot lifecycle management for data lifecycle management activities, including managing the replication and the snapshots and the versioning of the snapshots and so on. And you will have to manage the infrastructure code versioning depending on the cloud provider, cloud formation, Azure resource manager templates or deployment manager templates and so on. You will have to manage depending on the cloud provider. You will have to be familiar with all the in a nested stack oriented approach of developing these application infrastructures, and you will have to manage the code versioning, all the state management that comes with the infrastructure as code. So infrastructure as code has enabled a bunch of capabilities that were not possible before. On the other hand, it has also brought in some of the complexities associated with it. So it's always a good and bad side of any new technology, and that comes with in infrastructure as code as well for cloud providers. And then on top of that, you'll have to manage all the KATS, Kubernetes Service Configurations Management, which means that you will have to look at your application configuration as a whole, depending on the namespace, and you will have to manage all of that. So in the end, you'll have to ask the question, is that a guarantee with respect to your application resilience? If the expectations from the business side is about 99.95, 99.9, or even 99, then do we have the chops to manage all of that and manage all the capabilities that is required in the backend, if it is human beings or the tools or the combination of tools along with the cloud infrastructure, APA, all of that? Do you have that, right? If that's the case, even if you got it, somehow managed to put in the resiliency required for some of these applications, do you have the ability to kind of manage the entire automation system over a period of time? Right? So those are the difficult questions, and actually difficult answers as well. It's not easy to, first of all, think about, lifting and shifting. Those projects are complex. So somehow you landed on the cloud providers in one of the zones. Now you'll have to really think about the resiliency of it, because you'll have to grapple with the possibilities of the complexities of rather not having the right skills on the cloud provider. So you'll have to search for particularly the DevOps engineers with the backend coding experience on the cloud platforms, and specifically if they are certified, that's good. Otherwise, it's going to be a problem. And then you will have to assemble a bunch of other tools with a combination of the tools available on the cloud service providers or the marketplaces. Then you will have to think about how to manage the resiliency. And that's where, Appranix gives you multiple levels of resiliency. You can think of us when you want resiliency, we call it as a level 1 resiliency between two zones within the same region, or between two regions, East Coast to West Coast availability and resiliency within the same cloud provider. And in this particular webinar, we'll be talking about how to go and recover your applications, especially when these applications run on the Kubernetes environment, from one cloud provider to another cloud provider. I mean, this is like pushing the boundary, pushing the envelope in terms of resiliency, and we want to be cutting edge. And so that you understand that there's not just one aspect of resiliency. There are 3 levels of resiliency that you could think of as you move towards modernizing your applications, either by cloud enabling them or creating them as cloud native applications as well. So the easy way to start is to go to any of these marketplaces. I mean, GCP marketplace, you go and search, straight away go to Google and search Google and Appranix, you will land in the GCP marketplace. Or the same thing on Google, you could search Appranix and AWS, you will land on the AWS marketplace as well. So once you subscribe, all you have to do is to go through that marketplace item and say subscribe from within your project or within your account on the AWS or GCP marketplace, where you can pretty much start with a very simple number 1 step, which is about just discovery of your existing environment. So without affecting your production, it's a read-only metadata collection so that we provide the resiliency necessary. So you start there, and then you kind of combine, depending on the application complexity, we allow you to combine services. For example, your application could be running on a bunch of virtual machines, or could be running on completely on Kubernetes as within one of the namespaces. And some of the data services might be running external to Kubernetes, typical situation that we have seen with multiple customers that are moving and modernizing their workloads on the cloud platform. So in these situations, you could discover, let's say, Cloud SQL or RDS, and combine that with your GKE Kubernetes application as one assembly, and then put a policy together. So it's as simple as that. And then Appranix automatically gives you this application environment time machine. Let me pause here. This is tremendous innovation around what was not possible before and what is now possible because of the cloud infrastructure, a consistent cloud infrastructure with consistent infrastructure services around compute, storage, networking, load balancer, and DNS, and so on. That combination enables you to create application environments, copies of application environments that can be maintained just like an Apple time machine, right? So think of this as an application environment time machine for your cloud application that's automatically created and maintained based on the policies. That way you can go back in time, right, at any point in time and recover your application with a single click for rollback purposes, failover purposes, or even create a copy of that environment for multiple other use cases like test dev, patching, analytics, and so on. So tremendous benefits with respect to maintaining that automated application environment time machine. So with that, you can pretty much have what we call it as an powerful undo command, right? So if you are an SRE and completely familiar with the DevOps culture within your company, or you are putting together a DevOps culture within your company with all the tool sets for continuous integration, continuous deployments, where you have an ability to kind of create this deployments using some of the mechanism like CloudFormation or Terraform, whatever that is. Now we come in with a single line, we integrate with your CI/CD and extend that to something called continuous resilience for your applications. So pretty much, by plugging in this one particular line, APS protect your assembly and assembly name, that's it. We track all the release numbers. Whenever you do your deployments, that release number is attached with the deployment, and an application environment copy is automatically made for you as part of the time machine, right? So that you can go back, roll back, recover, failover, create environment for multiple purposes, as I mentioned earlier. So that's a tremendous capability that is not available in the marketplace today, and Appranix has introduced that to as an innovation on top of the cloud platforms. So if you peel under the layer, right, under the hood, what's happening is that you start with our SaaS platform, read-only access, nothing else. It's not going to disturb your production environments. And assuming that you are running this complex infrastructure, you don't have to worry about cloud infrastructure if you're completely running on the Kubernetes environment. But even then, you may end up using Cloud SQL as your serverless database engine. So if that's the case, then you'll have to really think about other components that make up that particular application running in one namespace or multiple namespaces, right? Then our system automatically builds that time machine. You can go back in time and pick one of these and then take care of recovering that application, either in a local region or a remote region. In this particular case that I'm going to demo is going to be on a different cloud altogether. So that's going to be one of the coolest things that we have done so far. So you're not alone. Companies like Pragya rely on our services. Some of the other larger enterprises, which I'm not able to publicly do it here, larger enterprises that have deployed on AWS, they are running about 550 virtual machines, a bunch of applications, a $10 billion revenue producing company. And another company which manufactures a lot of, pretty much they own a 30% of eyewear and the frames and the lenses market, and they are one of our huge proponent of technology as well. So with respect to today's demo, what we are going to do is we are going to work on an infrastructure that is already running on Google Cloud Infrastructure Services, where Cloud SQL is a database engine, and the GKE is a Kubernetes service. This is the application called SockShop, just standard distributed application that is available as an open source. So we leverage that to give you, what is possible with a distributed application, right? And then we will fail over this container application to the Azure environment, where we are, the AKS service is already running, Azure Kubernetes service is already running on top of the Azure environment. Or you could even run your own self-managed Kubernetes on top of Azure, that is not a problem as well. So, we can even help you in terms of running that as well. So this is going to be our demo, and then with respect to buying it, it's very, very straightforward. You can enter through the marketplace, you can subscribe directly, and you can see the capabilities that are available in the marketplace. Very, very straightforward pricing model for us. So with respect to Appranix, compared to either creating homegrown systems or even buying third parties and integrating them, right? Appranix delivers a quick and a solid return on investment. So if you buy Appranix, you don't have to worry about local region VM backup and recovery. You don't have to buy that. Remote region backup and recovery. You don't have to buy that. Data lifecycle management with replication. So you don't have to worry about actually managing it, even if you try to leverage from AWS, the capabilities are already built into it using the API directly from the cloud providers. So it's all cloud native. Recovery systems like VMware SRM, there is none available on the marketplace for cloud providers, cloud platforms, and you don't have to buy any of that. If you are running on a Azure, site recovery, Azure site recovery is a good solution if you are moving from your on-prem to Azure. That's the only service that is kind of available. But within the cloud region, within AKS, you do not have the capabilities for other cloud platforms like AWS and Google. And then tremendous amount of human labor. You will have to think about configuring the boot order, even if you bought like VMware SRM. How do you know the boot order when your application components are changing all the time? You'll have to manage all the IP addresses, VPCs, and application recovery. So things that I mentioned on top of all the cloud versioning, cloud infrastructures, code versioning, management of the state, and so on, all of that has to be managed. So with Appranix, you get all of that with a full application environment recovery, full cloud configuration management, all of that completely built in. So let's check out how that actually works. So moving over to the demo, what I'm going to do is to show you an application that is already running, and that application is this, a SOC shop application where you can log in and buy. I have an account here already, so you can buy broken socks, right? Literally broken socks. Let me go to in the catalog. This is an interesting thing. So this broken socks costs only $99, $100 by the way, and some change. And the torn socks, obviously we are not going to buy any of this. And it's a, by the way, this is a real world application. It's one of the e-commerce companies in the UK. They are super helpful in terms of open sourcing their application, and we works kind of massage it and then make sure that the application is available as an Apache too. So this application runs on containers completely, and that application actually looks like this in terms of the complexity of the application. So you can see the connectivity between the components. There are a number of containers that are running in the backend. The namespaces, even if you kind of isolated to the namespace, this is one application that is running here. So this application, what we are going to do is to intentionally disrupt this application. So if you look at the application backend itself, the Kubernetes service, we are using Google Cloud Platform Kubernetes engine. There are two clusters that are running here. One is the production GKE cluster where the SOC shop application is running, and this is created for other demo purposes, so you don't have to worry about it. And it is running on the US Central region. So if you explore this Kubernetes environment, it's a typical GKE environment. If you go into the workloads, you have all the applications components, or the microservices rather, that are running here. So you can see cards, catalog, front end, orders, and so on. These are all the components that you will see here as well. So if you look at the containers, catalog, cards, front end, all of that are running right here in this particular environment, GKE environment. So what we are going to do, I'm going to disrupt this application, meaning that kill all the parts on this GKE engine. and show that the application is not running, and then move over to Azure where the AKS service is already running. So you can see the recovery cluster is already running, but there is nothing in there, right? So if you connect, so in order to get to the Kubernetes dashboard, you will have to do a little bit of tricks here on the Kubernetes on the shell on Azure. So this is Azure. So you can see Microsoft Azure as a service running, but we are connecting to the shell because there is no built-in Kubernetes dashboard, just like GKE. It's a little tricky to kind of do that. So what I'm going to do, I'm going to just execute a couple of scripts here, a couple of, just 2 lines basically here to get that access to the Kubernetes dashboard. So Azure has the Kubernetes engine running, and the way to get to the Kubernetes dashboard is to get through a command that is executed just like this, so that you can browse that environment that doesn't directly go there. So what I'm going to do is to just click this particular environment so that you can get to the Kubernetes dashboard that is running on the AKS. So as you can see here, this Kubernetes dashboard on AKS, once it comes off, namespaces, there are no namespaces with respect to SockShop. So SockShop is not running at the moment. So let's do a refresh of this. This is a little bit of application refresh problem. So as you can see, the SockShop application is not running in this particular Kubernetes environment, right? There is nothing here. So what we are going to do is to intentionally kind of disrupt this application. So for that, all I have is a couple of scripts that I will do. So I'm going to do disaster script. And that one, what will happen is that it will fetch the GKE engine in the parts, and it will take out all the parts. So you can see some of the parts are going down, right? They are getting killed. So once you kill these parts, then if you access your application here, the application is down as well. So the application is completely done. So the disruption was initiated. Now what we are going to do is to go to Appranix. So far, you don't have to worry about Appranix because you have been running your application peacefully on GKE and so on without any protection. Now the situation has really happened, meaning that your application is down. Now what you do, you have 2 choices. One is you try to kind of call Google support and then try to come up with a strategy to bring back your application, or you have some other mechanism to redeploy your application within Google. That's also possible. And now the entire region is down. Now what do? You'll have to think about other mechanisms like, oh, can I go to AKS? Because Azure seems to be available. So that's like pushing the boundaries, right? Now, if you had Appranix Service, you subscribe to Appranix Service, what you have to do is to get to Appranix Service here. You configure your cluster. It's very, very straightforward. Cluster name, cloud selection, which we already configured. So it's a straightforward one to get to the cluster itself. And that is how we configured the production GKE cluster. So you can see these applications are running, and you put a protection plan. In this particular case, it is a 1-hour protection plan. So, and that the policies are very, very straightforward. So it's a hourly protection policy, and this is where the time machine automatically kicks in. So the protection timeline, it's automatically taken care of for you. So every hour it goes and works for you and creates that time machine for your environment, right? It gets copies of that environment automatically taken care of, and then in the back end, you can check out what's happening with respect to the protection is succeeded or not, all of that. And it is delivered as a service. So if there is a problem, we check it, make sure that your SLAs are properly satisfied. So to a point where the older disaster as service capabilities are, most of this are automatically taken care of by Appranix Service. And you can have multiple policy templates, and depending on the situation, you can create not only hourly policies, weekly policies, monthly and yearly policies as well. So pretty much the backend backup capabilities using the snapshot mechanism is also provided for free here, right? So that you don't have to worry about that capability. Now, what we are going to do is to get to that particular time frame, and I'm going to just go back in time and recover it. That's all you have to do. All I'm going to do is to select the AKS cluster, right, and recover it. So the activity will start in terms of recovering this particular cluster. So here you will monitor that. Let's go to refresh it, and let's see if the sock shop application automatically appears here or not. And then you will have to switch over the DNS, because there's a DNS switch, again, very, very specific to a particular organization. And, we'll have to just run a quick script to kind of switch the DNS so that you can retain the same DNS entry, but it basically points to the AKS environment of the Kubernetes. So here, let's see if it comes up here, and keep monitoring that. It's in progress, so it is recovering all of that containers, and slowly the entire sock shop environment will appear in about a few minutes. So now it's here. So sock shop, and sock shop has a bunch of components. There are components that are getting started. So Kubernetes will take care of starting these parts, right? So we pretty much initiate the configurations required for Kubernetes and make sure that the containers all properly kind of deployed into this new environment, make sure that all the configurations that happen to be in the GKE environment are all copied so that your particular namespace appears as is without conflicting with other namespaces within the GKE environment. So, so you can see the recovery is complete. So once the recovery is complete, what we are going to do is to switch the DNS. So it's called update DNS. So let's update the DNS records. Make sure that the sock shop application is still not up, because the DNS will take about 30 seconds roughly to update. So it's pending in terms of while that is happening, you can explore other parts of your recovered system, and also you can check out what's happening on the Azure side as well. So here your cluster is changing. Obviously, you will end up paying a little more because you are consuming more Azure components here, and the node pools. Again, Azure is still kind of working through their Kubernetes service, a bunch of enhancements that are coming in more and more. So keep monitoring this space. But in any case, you have the capability to kind of deploy your own Kubernetes environment, or you can access AKS service. So once that is available, let's see if the DNS update is still pending, because it takes about, DNS services are tricky. They are scheduled and it takes time to complete. So obviously it took a little bit of time, but it is done. So in that case, what we are going to do is to refresh this application. Voila. So the application is back. I'm going to check by logging in rather, and the application environment with all my socks, colorful socks, my broken socks is also intact. Literally in about less than 7-8 minutes, I am able to recover my application in another cloud, right? From GKE to AKS. Right? That's a tremendous, powerful tool in your bag to first of all be compliant, right? You can become compliant, and immediately for many purposes, SOX compliance, SOC compliance, and so if an auditor comes, you can very easily say, here it is, compliance. Here is your report, ready to go. So you're off the hook. And if the situation really happens, if a disaster happens, if a ransomware attack happens, if a bad deployment happens, right, you're ready to provide an environment that works, right? That's a guarantee. And the third thing is that if your application developers require new test environments, go ahead and deliver them in no time, right? You can even tell them to automatically access through their, version from the GitHub, because the time machine maintains different versions. They can go back in time, right? If you have some kind of a testing that is required, you can go back in time, right, and access that particular version of the application, because the entire environment is going to be provided for you. So you don't have to worry about creating the entire application environment. So everything is automated completely and on top of your beloved cloud provider, right, using their own cloud native capabilities. So this is all good. So what I'm going to do is to actually, reset that environment so that my application is back to where it was. So what we are going to do is to reset so that I can bring that application back to GKE. So what will happen is that it will kill this particular namespace on AKS so that everything is cleaned up, because you could have done simple testing on AKS, right? Whether the applications actually come up or not. The real recovery was done, but now it's all gone. So you can see there is nothing to display. So sock shop is done. So you have nothing here in terms of, let's see if there is anything that is left. It's terminating. So it's terminating for now. And on the other hand, you can see this GKE environment sock shop will be automatically deployed. So it's all zero. I mean, nothing is deployed because all the parts are down. So once that reset is done, deployment is automatically scaled. You can see magically that application will be back online with an update to the DNS. So here it is, the parts are getting started. Anyway, so your application will be back online as if nothing happened, running on GKE as opposed to AKS, and you are good to go. So let me stop here and see if there are any questions on these capabilities. By the way, you will have access to this recorded webinar, so do not worry about taking care of some of the questions. You might have some questions later on because we are pushing the boundaries here. How do you really fail over from one cloud to another cloud? So that's the type of capability that's now available, that's now possible, that you can access today directly from the marketplace. So if there are questions, you can put your hand up, or you can use the chat window to ask the question as well. Let's wait until this application comes up. And again, the DNS switch will take a little bit of time. Apparently all the parts are up and running, but the DNS change is happening right now. So let's wait for another 30 seconds for the DNS entry to take place. And once that is done, you are ready to go, as if nothing happened on your production environment as well. So in about 20 minutes, we went to another cloud, an alternative cloud completely, and then back again in the primary cloud, right, for your applications. I mean, that's tremendous in terms of what is possible with wonderful hyper cloud platforms today. So you can see this application is back. You can log in and check everything is running okay here. Your own, tone socks is right here. So it appeared at the bottom for some reason here. And in any case, this Azure environment is completely cleaned up. So nothing here. So let's refresh it to make sure that that environment is back to where it was without consuming any other infrastructure on the AKS side, right? So there is nothing here. All of that is gone, even though it's just some UI elements on this particular place. So, right, and that's it. There is no sock shop at the moment. I'm completely off. So that's completely cleaned up, and your application is back online in the production environment as if nothing happened. So if there are no questions, thank you for your time. It was a pleasure kind of putting this webinar so that your teams could get educated. You can spread the knowledge and the tools that are available in Appranix service. Okay. Thank you very much. Have a great day.